Linear inequalities from standard form. This lesson is a follow-up to graphing linear inequalities, a video I recorded in December 2008. For this video, we will set aside the graphing calculator and use plain old-fashioned graph paper. A linear inequality in standard form looks very much like an equation in standard form. Here we have the equation 3x minus 4y equals 12, and the inequality 3x minus 4y is greater than 12. The only difference between these two relationships is the symbol of equality. In the case of an equation, it's an equal sign, and in the case of an inequality, it's the inequality symbol, in this case, greater than. In an equation, we are solving for a line, but in an inequality, we are solving for a boundary line because the line we graph is a boundary. On one side of the line is the solutions, and on the other side, there are no solutions. On this particular inequality, the shaded area above the line is the set of solutions and the unshaded area below contains no solutions. Since the boundary line is solid, that line is also part of the solution set. We need to find the equation of the boundary line. We need to draw a dashed or solid line for the boundary line, and finally, we need to shade on one side of that line to represent the solution set. Let's graph this linear inequality. 3x minus 4y is greater than 12. When I get ready to graph, I like to call it not equal to, but greater than. We'll get to that a little later. I like to graph lines in standard form by finding the x and y intercepts. To find the x-intercept of this boundary line, we can cover the y term with our thumb and see what's left. We have 3x is greater than 12, so we can write that off to the side. We divide both sides by 3 and get x is greater than 4. We mark the x-intercept at x equals 4. We solve for the y-intercept by covering up the x term. What's left is negative 4y is greater than 12. But will it be greater than? Not so fast. When we solve an inequality by dividing by a negative number, we have to change the direction of the sign. So it will be y is less than negative 3. Now we draw in a point at the y-intercept of negative 3. With the x and y-intercepts drawn, we're ready to draw the boundary line. For inequalities, there are two kinds of boundary lines, a solid line representing equal to, and a dashed line when the boundary line is not part of the solution set. Since this one is less than, it's a dashed line. We draw a dashed line using these 2 points, and since the sign is less than, here y is less than negative 3, which way do we shade? Less than means down or below, so we shade below the boundary line. So this is the graph of 3x minus 4y is greater than 12, actually. I believe in checking because it's easy to make a mistake with a sign or something like that. I like picking the point 0, 0 since the math is so easy, so we mark the point 0, 0. We substitute 0 for x and 0 for y. That leaves us with 0 is greater than 12. Is 0 greater than 12? No, it is not. So therefore the point 0, 0 is not in the solution set or the shaded area, showing us that we shaded below the line correctly. Check. Let's look at this inequality, which is 5x plus 6y is greater than or equal to negative 30. Again, we use our thumb to cover the y term. That leaves us with 5x is greater than or equal to negative 30. We solve for x by dividing both sides by 5 to get x by itself, so x is greater than or equal to negative 6. We mark the x-intercept on the x-axis at negative 6. We now need to find the y-intercept, and we start that process by covering the x term with our thumb. That leaves us with 6y is greater than or equal to negative 30. We solve for the y-intercept by dividing both sides by 6 so that y is equal to and greater than negative 5. We mark the y-axis at negative 5. Now using the x and y-intercepts, we draw the line. And what kind of line is that? A solid line, since the symbol is equal to and greater than. And since it's greater than, which way is greater than? Well, up is greater than, so we shade upward. Finally, we mark a point on the graph, and 0, 0 is the easiest to use. Since both x and y are 0 for this point, that gives us 0 is greater than or equal to negative 30. Is that correct? Yes, it is correct, and because that is in the shaded area and part of the solution set, we have shaded the right way. Check. Let's look at this one. Negative 8x plus 7y is greater than 56. Remember that when it comes to graphing, it is helpful to say not equal to but greater than, so we keep in mind the type of boundary line we need to draw. Stop the video. I recommend getting out some graph paper and trying this one yourself. When you've finished, restart the video to see how you did. First, we cover the y term. That leaves us with negative 8x is greater than or equal to 56. We solve for x by dividing both sides by negative 8, and since 56 divided by negative 8 equals negative 7, negative 7 is what we mark on our x-axis. Now we solve for the y-intercept by covering the x term. That leaves us with 7y is not equal to but greater than 56. We finally solve for y by dividing both sides of the inequality by 7. So since 56 divided by 7 is 8, we have a y is not equal to but greater than 8. So do we divide by a negative number to solve for y? No, since we did not, we don't have to switch around the inequality symbol. Now we mark the y-intercept at 8. And here we draw the line. It is a dashed line since it is not equal to but greater than. And since it's greater than, we need to shade which way? Well, upwards. And we finally check the point 0, 0 to see if it's a solution. Since it's in the unshaded area, it should not be in the solution set. We substitute back into our original inequality for 0, 0. That gives us negative 8 times 0 plus 7 times 0 on the left. And that gives us 0 is greater than 56. Is that true? Is 0 greater than 56? No, since the point 0, 0 is in the unshaded area, that proves that we shaded correctly. Check. Let's look at graphing this inequality. 2x minus 9y is less than 18. For purposes of graphing, I would like to call it 2x minus 9y is not equal to but less than 18. Stop the video. I recommend getting out some graph paper and trying this one yourself. When you're finished, restart the video to see how you did. First, we solve for the x-intercept by covering the y term. That leaves us with 2x is not equal to but greater than, but less than 18 rather. We find the x-intercept by dividing by 2. So since 18 divided by 2 is 9, our x-intercept is 9. We mark that x-intercept on the x-axis at 9. Now we find the y-intercept by covering or hiding the x term. That gives us negative 9y is less than 18. We find our y-intercept by dividing by 2, and since 18 divided by negative 9 is negative 2, our y-intercept is negative 2. To solve for y, did we divide by a negative number? Yes, we did. So we're going to need to switch the direction of the sign. And that's going to be y is greater than negative 2. And we mark the y-intercept at negative 2. Now we draw the boundary line. What type of boundary line? Since it's greater than, that would be a dashed line. Which way do we shade? Greater than means up, so we shade above the boundary line. All it remains to do is check to see that we shaded correctly. Using 0, 0 again, we replace x with 0 and y with 0. So we have 2 times 0 minus 9 times 0 on the left. Is 0 less than 18? Yes. And since 0, 0 is in the shaded area of the graph, we know that we have shaded correctly. Check. To summarize, first find the x and y intercepts by covering the y and x terms respectively. Then solve for the x-intercept, and then the y-intercept. We mark the intercepts. Then draw the boundary line, dashed for not equal to, or less than, or greater than, and solid for equal to. Now we shade above or below. Greater than is above the boundary line, and less than is below the boundary line. Finally, we use a point to check if the correct area was shaded. 0, 0 is usually the best coordinate to check, since the calculations are really easy. This has been Graphing Linear Inequalities from Standard Form. Thanks for viewing.